Hello students, today we will solve a question based on electric flux. So the question goes like this. Electric field components are Ex equals to alpha x to the power 1 by 2, Ey and Ez equals to 0. Here electric fields for the x-axis are given with this relation alpha into x to the power 1 by 2, and electric field for y-axis and electric field for x-axis are 0. There is no role play on this particular axis and this particular axis, in which alpha's numeral value is 800 Newton per coulomb per into meter to the power 1 by 2. This is 1 by 2. So value of alpha is given by 800 Newton coulomb per coulomb, and meter is not in negative value, it is half. Okay, so we need to calculate. First option number A is flux through the cube. What is the number of electric field lines coming from the given surface? Second, charge within the cubes. Okay, within this cube, what is the charge held by this cube? Okay, so here we are assuming that the length of cube, that is side of cube A, equals to 0.1 meter. This is a cube of side A. This is a cube of side A. This is y-axis. This is x-axis, and this is z-axis, and this is x-axis. Okay, and this is our cube placed here in the space. This is our x-axis, and the faces which are in relation with the x-axis is this face and this face. These two faces have relation with the x-axis, whereas just see, I am drawing with the yellow one. This particular face is in relation with z-axis, and the light green part, this one face is in relation, and this one face is in relation with the other axis. So the only thing which we need to calculate at present is relation of these planes, the faces of the cube which are on our x-axis. Why so? Why we just want relation for the x-axis? As the question states, see the question very carefully. Question says we have electric field for x given as alpha into x to the power half. But what about electric field via y-axis and electric field at z-axis? In the question it is given 0. So these 1, 2, 3 and 4, these four faces of the cube do not play any role in flux through the cube. The only faces which are playing role is 5 and 6. I will write here flux contribution is from faces 5 and 6 which are on x-axis. Okay, now other thing which we need to know is this distance from origin O to this point, this particular point is A, and again from origin to this particular point is A plus A, that is 2A. Okay, this point to this point from origin, okay, from origin to this point, at this point this is our A distance, and from here to here it is again A. So adding both these it will be 2A. Adding both these it will be 2A. Okay, this is our distance. We got how we are calculating A and 2A. When we will go on solving this problem, so we will start solving this problem now. See, this is the given relation of electric fields passing through the surface. At y and Ez it is 0, and the value of alpha is given 800 Newton per Coulomb meter to the power half, and a value of A is given 0.1 meter. These are the given things in the in our problem, in our question. Given information in question. Okay, so flux through the cube, we will start finding the flux through the cube. Only the x component are valid here. I will make one more rough diagram over here. This is our x. Okay, so this cube is over here like this. Wait a minute. This is the cube, and over here only this particular surface, which I'm putting the shades, will give us electric flux, and this one surface will give us electric flux. Only these two surfaces will give us electric flux. So our x-axis is in this direction. This is the direction of x-axis. Positive x-axis will move in from 0 to this side. So in this case, electric field will come out from this surface, will be in this direction. This is the direction of electric flux lines from our this surface, and from this surface electric field lines will come from like this. So with respect to positive, these are having positive value, and with respect to this they are having negative value. So this, why I am defining these two directions of the field lines. Why? Because we need to find out the theta. Why do we need to find out the theta? See, come to the left corner. What is the formula for flux? It is xi equals to electric field line, vector component of electric field line, into the surface area, and both are in vector component. They are denoted by a dot component, and when we remove this dot component, it will be E del S cos theta. When we see dot components gives cos, and cross products are removed by sign. I will give you one example, like A dot B are two vectors summed up. When we are calculating them in a scalar way, it will be AB cos theta. Similarly, A cross B in vector component, when they are converted into the scalar calculations, it will be AB sin theta. Similarly, we have E dot del S. It is converted into the this one scalar way, so that we can make the calculation, and it will come around E del S cos theta. So we need to define theta in this diagram. For that, we need to define the positive and negative components of electric field. So this is negative component. So here the theta will be minus pi by 2. See, this is our x-axis, and this is the direction of E. Both are making which angle? Both are making no angle with each other. They are, in this case, they are anti-parallel. And when x-axis is going in this direction, as well as our electric fields are going in this direction, these are parallel. What is the angle shown by the parallel lines? Theta is 0 degree. What is the angle shown by anti-parallel lines? It is theta equals to 180 degrees. Okay. Now I'll explain what is the value of theta 0 and theta 180. Cos theta equals to cos 0, this is 0, it is equals to 1, and cos theta when it is equals to cos 180 degree, it will give us value of -1. Okay, value of cos 180 degree is -1. So these values we will be substituting in our solution. Now we will go back to the solution where we will find the flux through the cube. Electric field has only an x component for the force perpendicular to x direction. Between E and del S we have angle plus or minus pi by 2. And flux is given by E dot del S, 0 for the faces 3, 4, 5, 6, the other faces I have told it's 0, and only for the faces at x we will have flux. Now the magnitude of electric field at the right face will be given in this way. When we are going with the right face, see in this diagram, which one is right face? Right face is on the right hand side. This one is right face, and this one is left face, and in the previous slide I explained this distance is a, and from origin to right face distance is 2a. So we will have electric field lines given at this point as alpha x to the power 1 by 2, where alpha will be alpha only, and for a we will substitute it as x. So this is the solution, overall solution given over here. See this and this. I will explain the solution in this right part. Just see the detailed solution, how we got into this conclusion. Xi equals to E dot S for x-axis, and for y and z value of E equals to 0. Now for this one we need to find R and E left, and that will be multiplied by the surface, okay, for the x. Now electric field at right will be given as our alpha x 1 by 2, x to the power 1 by 2. It is the relation given in the solution. Relation given in question. Okay, then ER will be equals to alpha into 2a to the power 1 by 2. Here x equals to 2a, that is the distance from origin to right side. I explained in this, right? So it is 2a. This is our one equation. We will keep it in a box. Now we will define E at our left face. It will be again alpha into x to the power 1 by 2. Alpha will remain alpha, and x is a here 1 by 2. Here x equals to a. Y distance from this origin to our left side is this point, is a only. So x equals to a. So this is our second equation, EL. We will keep it in a box. Now see here, this is our flux. We need to find flux in this question. What was our requirement? Our requirement was flux. So flux equals to E left into E right, alpha a 1 by 2 plus alpha a 2a to the power 1 by 2 into del S. So what is the value of del S here? The surface del S will be different for right and different for left. It will be different for right, different for L. So we have to again segregate this. We have to again segregate this as del equals to for left. This is not del, this is xi. Flux at the left side equals to electric field at left side into the surface area. Electric field is given by alpha a to the power half into the surface area will be del S only into cos theta. Here on the left side cos theta is 180 degree. At left face theta equals to 180 degree and cos theta will come -1. So our equation will become E into this. This one is in dot product we have vector. Now we have scalarized it and these are not anymore scalars. We can give them the value. Okay. Similarly, del at right will be E del S. That will be positive. Why? Because theta is 0 degree and cos 0 degree equals to plus 1. So this is our flux at right, left and flux at right. Now the total flux, see, flux at left, flux at right. I have explained it here, right? And how does this A square came? For this one face of cube, this is A, this is A. So what is the area? This is area vector, right? This is area. Del S gives us area. So this is area vector. So A into A will give us del S. It is equals to A square. That's how we are getting A square here and A square here. Now the net flux to the cube will be given as xi net equals to xi at R plus xi at L. So xi at R is positive value. Xi at R is positive E del S, whereas xi at left equals to minus E del S. We will substitute these values and we will get E del S minus E del S. This is left, this is right. Always write this left and right values, otherwise these two will cancel out. Then what will be the effect? Nothing. Okay, so always mention this is electric field at right, which is different from the electric field at left. Now this will give us electric field at right is alpha 2A half into del S is A square minus alpha A half into A square. Okay. Now this will turn out alpha under root 2 into A to the power 1 by 2 into A2 minus alpha A half into A to the power 2. What is common here? I'll mark it with the red ink. This is common, this is common, this is common, this is common, this is common and this is common. These are common values. This is one value, this is another value, and these two values, these three things are common in nature. So we will take them out. Alpha 1 by 2 into A square. What is left? Minus 2 minus under root 2 minus 1 is what we are left with. Now these two are same values with different powers. So we can write them as the same entity like this into A to the power 2. It will come around A to the power 1 by 2 plus 2. This will be expanded as binomial addition only. 2 is the LCM, 1 plus 4, and it will come 5 by 2. So here we will get A to the power 5 by 2, right? Powers are added when the two things are multiplied. Two same things are multiplied, at that time power are added, and when the two same things are divided, power are subtracted. Okay, so we added the power here. It will be alpha A 5 by 2 under root 2 minus 1. Here we have the value of alpha as 800 and value of A as minus 1. We will substitute these two values in this equation, and we will get an answer of electric flux to be equals to 1.05 Newton meter square per coulomb. Newton meter square per coulomb. This is our net electric flux in the phase 1 and phase 2 which lie on x-axis in the given cube. Okay, net flux. Now our B option was charge within the cube. We need to find charge within the cube. Okay, and to find the total charge we can use Gauss's law or the Coulomb's law. So we are not using the Coulomb's law here, we are using Gauss's law. Why? We are using Gauss's law. Why we are using Gauss's law? Gauss's law states that in a given system which is enclosing a charge q, a given system which encloses charge q will have flux equals to charge divided by epsilon naught, or 1 by epsilon naught into the given charge, 1 upon epsilon naught times the given charge, flux enclosed. I will write here for your reference. Gauss's law states flux given by an enclosed by an surface enclosing charge q is 1 by epsilon naught times the charge q. Okay, so this is how we get epsilon naught equals to 1 by epsilon naught, xi equals to 1 by epsilon naught into given charge q. This is the Gauss's expression. So we will be using this Gauss's expression. From the previous equation we got the value of this, and we know epsilon naught have a static value. It's not a changeable value. It have a static value of 8.854 into 10 to the power minus 12 coulombs. 12. Okay, we know this is the value. It have these units as in the opposite way of the units of this one. So from xi equals to 1 by epsilon naught into q, what we need to find, what is the unknown quantity? Unknown quantity is q. Unknown quantity is q. So q will be equals to xi into epsilon naught. Xi's value is coming from here and epsilon naught's value is constant, that is 8 into 8.854 into 10 to the power minus 12 coulombs. So we will multiply these and we will get the charge. So what is the charge? Charge contained by the system is 9.27 into 10 to the power minus 12 coulombs. This is the charge contained in the cube which gives electric flux of 1.05 Newton meter square per coulomb. This is the charge contained by this system. So that is how we are finding the flux. We are finding the charge related to that flux using the Gauss's law. This was quite a simple problem. The only thing was to understand which surface is giving you the flux and which surface is not giving you the surface, and how we are measuring the distances for the electric field lines. Hope you understand this question. So see you in the next class. Have a good day.